Hello everyone, welcome back to the VTU C Programming Lab series. We were covering the series of VTU lab termworks in the in this series, and we will continue with the next termwork, that is termwork 5 on implementing the matrix multiplication in C and validating the rules of multiplication. So first we will discuss the matrix multiplication, and we will then go to the logic of implementing it in C, and then we will write the program. So first we will see what is the validation of multiplication and how it works. So whenever we need to multiply matrix to matrix, we first need to consider their dimension. Say we have two matrix A and B. The first matrix dimension is m cross n, and second matrix dimension is n cross p. Then the there should be a common between matrix A and matrix B. That is, the number of columns of A should be equal to number of rows of B. Means whatever n we are seeing here, the n should be same. That's why we have denoted it by common variable n. Because whenever this rows of columns of A is equal to rows of B, then only we can be able to do the multiplication. And the dimension of product, that is AB, will be m cross p. The first matrix rows and second matrix column, that is m cross p, will be the dimension of AB. So that's it. And we will now look at the multiplication thing, that is how multiplication actually works. We have considered two square matrix over here. Square matrix means a matrix whose rows and columns are same, means they are in the form of a square. Here we have uh, two matrix A and B. The dimension we need to check first, that is we need to validate the multiplication first. After validating the multiplication, that is number of columns of first matrix should be equal to number of rows of second matrix, then in that case we will be doing the multiplication. Here that condition holds true. Moving to the multiplication, we have A, B, C, D and E, F, G, H. So these are some random elements. How we should be multiplying? First, we need to consider the first row of the first matrix with first column of the second matrix. That is A into E plus B into G. You might have came across this matrix multiplication in your lower classes. That is PU or in any other courses. So the matrix multiplication is the same that we have learned in the mathematics. So how it works? A into E means the first element of first row of first matrix should be multiplied with first element of first column of second matrix. A into E, then continuing further, that is B with G. So AE plus BG gives rise to first element of the first row of the product matrix. Similarly, the to find the second element of the first row of product matrix, we need to multiply A with the F and B with the H. That is with this second column of the second matrix. Then we will be getting this second element of the first row of the product matrix. So this is how the matrix multiplication works. So here I have given one example. The same example we will be giving as an input in case of our to test our program's correctness. So you can consider we have a matrix of 2 cross 3 over here, 2 rows, 3 columns, and here we have 3 rows, 2 columns. So the dimension validation holds true here also. Coming to multiplication, take the first row of the first matrix, take the first column of the second matrix, multiply the respective elements, that is 1 into 10, 2 into 20, 3 into 30. And similar way, do it for other elements, and store the sum of multiplications in particular variables, or you can, we will be actually here creating a array of 2 dimension to store these numbers, and we will be getting the resultant matrix in the form of array. So this is what is required as a matrix multiplication. So this is just some sample input output format. Just go over this. That is how we are taking the input. We are first taking rows and columns of the first matrix, then rows and columns of second matrix. Then we are taking the input from the user about what are the elements of first matrix, what are the elements of second matrix. Then we are multiplying and outputting the result, that is resultant product matrix. So this is the agenda of the program that we are writing. So let's move ahead and write it. So we will begin by having by including necessary header files, hash define, stdio dot h. We will also include hash define stdlib because we might need the uh, exit function to be implemented. Um, Once we have this, um, what we will do is we will have two, we will declare the matrix, that is matrix 1, matrix 2, and multiplication matrix in as a global variable, so that we can uh, get the uh, so that we can access the matrix from any of the function. It is like a global function. So sorry, it should be hash include. My bad. Here it should be hash define. So we are doing max underscore rows. First, we are doing this so that we can specify the maximum rows possible in a matrix, and we will have a hash define max underscore columns, which will which is to indicate that maximum columns possible in a matrix, which we are declaring it as a global. So let's declare the global variables that are matrix 1. In the we, as I said, we are storing the element data in the form of a matrix, in the form of array of the matrix data, so that we can iterate over the matrix and find the multiplication. Let's have the max underscore rows. Let's have max underscore calls. Yes, same way do it for uh, matrix 2. We are just declaring two-dimensional matrix containing the rows as max underscore rows and the columns as max underscore columns. The reason for declaring them as a global is because we can access these matrix from any of the user defined function across the program. If we specify it in any of the functions, say main function, we need to explicitly pass it into other function. So it is better to declare them as a global. I am having a resultant matrix as MUL multiplication multiplicated matrix, max underscore rows for this also, and This will do the declaration of matrix. Let's go to the main function and uh, try to take the input from the user. First, we need to declare some variables. The variables required as of now are uh, number of rows of first matrix, number of columns of first matrix, and same way number of rows and columns of second matrix. So I will have R1 comma C1 stating rows and columns of first matrix, R2 comma C2 stating rows and columns of second matrix. Let's go to let's print a message saying enter the rows and columns of matrix 1. So they will be entering it into the input console. We will be reading them through the scanf function. Why percentage %d? Because we are reading the integer data. The percentage %d is a format specified for the integer data. Let's go to the second matrix. Same way, we will read the data required for the second matrix. Yes. Once we do this, another thing, while reading the scanf, we need to specify the ampersand so that so that we can store the data at exact location or at the address of those variables. Once we have read the data, first step, as I said in the presentation, first step should be validating the dimension. So let's have a function for that, for validating, and the return type we will keep it as a int. No, return type we will keep it as a void because it doesn't return. If it is means if the validation fails, we will directly going to terminate the program. That's how we are designing. It requires 4 data: R1, C1, R2, C2. Whatever we have read from the user, all these are required. So that actually C1 and R2 will suffice. But let's design containing all those 4 variables. And what we need to check, how the matrix validation is done. You can see here, we are considering the column of first matrix and row of second matrix. Both should be equal. If they are equal, proceed. If they are not equal, terminate. So if column 1 is not equal to row of second matrix, then terminate. Let's say invalid dimension, not invalid, incorrect, I will say incorrect dimension for the multiplication, and I will say exit of 0, or not exit of 0. Exit of 0 indicates successful termination, but here we are doing unsuccessful termination. Means uh, we are saying that the generation of multiplication result is unsuccessful because of incorrect dimension. So exit of 1. We are not writing the else part, that is when C1 is equal to R2, because when that is the case, we will just proceed. We need not to print anything. So this is about validating the dimension. We need to call that function over here. We will directly call it and we will pass the required data in the form R2 C2. We are uh, passing the arguments required for that function. Now, the once we get to know that it is valid dimensions, we will say enter the elements of first matrix and we will read the data. For reading the data of two-dimensional array, you can see here, this is two-dimensional array matrix 1 containing rows and columns. We need two for loops. We will set up the two for loops so that one, that is ith variable loop, will be taking care of the number of rows and reading row data. Not reading row data, it is like incrementing the row and keeping track of the row. And the another inner for loop will be keeping track of the um, columns, like progressing through the uh, columns in a matrix. So I equal to 0, I less than ni plus plus. Here I will have similar way jth loop. Jth loop will be running from 0 till, sorry, not this ith loop will be running from I equal to 0 to I less than n, I less than R1 means till it runs till the number of rows specified in the first matrix, and the jth loop will be running till number of columns specified in the first matrix. This is we are doing for the first matrix. We have to do the similar way for the second matrix also. Scanf percentage d store it at the address of matrix 1 ith row jth column. So matrix 1 of I of j means matrix 1th rows, matrix 1's ith row jth column. We are storing it in the array whose name is matrix 1 in the ith row jth column. That is the simple meaning. And here the row and column index will be beginning from the 0, because we know arrays index will always be beginning from 0, not from 1. A semicolon, this will do the taking input of the first row, sorry, first matrix. Similar way we are doing for second matrix. I am just changing the required data. Here we will be storing it in the matrix 2, and here the upper limits are R2 and C2, which stands for rows and columns of the second matrix respectively. Once we read the data, next job is to uh, we will have the before we find the multiplication, what we can do is we can have a initialization of multiplication matrix, that is this matrix. We have created this matrix to store the um, result of the multiplication, so better we initialize it with zeros. So for that we will write one function initialize matrix. For this we only need R1 and C2, because the resultant matrix will be of the size R1 rows and C2 columns, as I said in the matrix validation. So for that I need to write a function. So this will also be in the form of void initialize matrix int R1 in C2. Once we have this function, what should be there? Again, a two for loop. So in the matrix, whenever reading, printing, or initializing, we should have two for loops because the matrix is getting stored in the two-dimensional arrays. So two for loop is a must for any of the operation. For multiplication, we will be needing three for loop, which we will discuss soon. I less than R1, I plus plus, have again a for loop for int j equal to for int j equal to j less than c2 j plus plus. Once we have this, we should have multiplication of I of j. Means in the ith row and jth column of multiplication matrix, set it to 0 so that it doesn't get initialized with any of the default values. That's the sole reason behind this um, uh, initialize matrix function. Now we will write the function for matrix multiplication. We need two more functions, one for multiply. This will do the matrix multiplication and it requires four parameters: int r1, int c1, int r2, int c2, because for multiplication all the four dimension needed. And we need to have another function void print matrix, because once we get the resultant matrix we should be able to print it. So it also requires again no, it requires only two parameters, int r1 and int c2, because we will be printing the resultant matrix whose dimension is r1 and c2. So we need to write the function description for these two. The multiply function we will write now. For multiplication, we need this is the main part of the whole program. That is how to multiply two matrix. For multiplication, we need to set up three loops. One will be keeping track of the, I will explain it with this. One will be keeping track of these rows. Another will be keeping track of these columns. Another is needed to keep track of each element in this row and in this column. Say for example, I am having a outer loop of I equal to 0 to I less than R1. That will keep track of first row, second row, third row, and so on. And the inner loop of that is int j equal to 0 to j less than c1. So that will keep track of these uh, columns. Sorry, j less than c2 it is because second matrix. So it will be keeping track of these columns like first column, second column, third column, fourth column, and so on, whatever it is. And another, that is k equal to 0 to k less than c1, means it will be keeping track of the each element in the matrix. Say I am in the first row, but I should be able to iterate over this 1, 2, 3, and any other elements if they are. So for that I need another loop. So that's why matrix multiplication requires three for loops. Let's implement it. Say for int I equal to 0, I less than R1, because we are iterating over the rows. I plus plus, have another for loop. This will be with the j variable. You can give the variable name of your choice, but these are standard, not standard. These are like most practiced one. C2 means jth loop will be keeping track of the columns of the second matrix, and another loop is to keep track of the variables k equal to 0, k less than c1, k plus plus. This will suffice. Yes. k equal to 0 to k less than c1. Yes, it is correct. Mm, Multiplication of I of j, because this is the resultant matrix in which we are storing the result. Here, in the how we are doing the multiplication, we are doing the multiplication of matrix one's ith row kth element, means this is ith row. In that kth element, that is each element, we are adding it to we are multiplying it with matrix 2's kth element of jth column. I hope you are getting the point. I will tell it again. Multiplication of uh, for this element. This is resultant matrix. So multiplication arrays ith row and jth columns element. How we will be getting? We need to iterate over the matrix once ith rows kth element, that is over each element. We need to multiply these elements with the matrix 2, that is second matrix kth rows, that is this is first row, second row, third row, that is kth row. The k we are taking to iterate over each element, kth rows jth column. So this will give us the desired result. Let me show it over here, and we need to add the sum of the all the multiplication to a single value. You can see here all these 1 into 10, 2 into 20, 3 into 30, all this multiplication I need to add and compress it to single variable, which is coming out to be here 140. Let's have multiplication of I of j equal, so we are adding it back to the variable. So what all should be multiplied? Matrix ones, ith row, kth column into matrix two's uh, kth uh, rows jth column. Matrix 1's ith row kth column and matrix 2's kth row and jth column. That is how the result should be generated, and this will work perfectly for multiplication. Let's print. Printing is simple. uh, just we will have one message say printf the result is, and we will have two for loop again to iterate over this I equal to 0 to I less than, say, r1 rows first, I plus plus, then the number of columns will be into j equal to j less than c2 it will be, and j plus plus, so that will multiply and keep the result. Sorry, not we need not keeping, we need to print the result of the multiplication matrix result we need to print. So have a printf function of percentage d uh, mul of I of j. Yes, multiplication arrays ith row jth column we are printing. That means we are printing the whole multiplication result matrix uh, of which is bounded by dimension r1 c2. That's why we have passed them as a arguments to this function, as a parameter to this function. And after each row we can have a printf backslash n, so that we can have the um, new line after each row is printed. After we print one row, we can have the new line so that the next row can be printed on new line, just for a good looking of the output. We need to call these two functions in the main function. We need to call these functions in the main function. multiply we need to pass r1 c1 r2 c2, then have print matrix r1 c2. That's how it needs, and just return 0. Yes. This is nothing but we are just calling these functions which we have discussed just now, that is initialize, multiply, and print the matrix. So I hope this idea is clear. Let me see whether it is working correctly. Yes, just a second. I will clear the terminal. It is asking enter the rows and columns of matrix 1. Let me take this example only so that we can check whether we are getting this desired result. So the rows and columns of first matrix, there are two rows, this one and the another one with 4, 5, 6, and 3 columns. So we enter it as 2 rows, 3 columns, 2, 3. That's it. For second matrix, uh, we have 3 rows and 2 columns. 3 rows and 2 columns. Enter the elements of first matrix. Means the dimensions are correct and it is correctly checked by the program. It is asking for enter elements of first matrix. 1, 2, 3, 4, 5, 6. Let me enter it as 1, 2, 3, 4, 5, 6. You can enter them in the single line also, no problem. Enter the elements of second matrix 10, 11, 20, 21, 30, 31. Let me enter in that format only 10, 11, 20, 21, 30, 31. Yes, and the resultant matrix is there is no space actually, but you can see 140, 146, 320, 335. 140, 146, 320, 335. It is correct. We are not getting space because while printing, we need to have a space after this percentage %d so that elements can get separated and have a new line character after printing the result is, so that the matrix can come on the new line. Let's try it again. I will enter the same input 2, 3, 32, 1, 2, 3, 4, 5, 6, 10, 10, 11, 20, 21, 30, 31. You can see 140, 146, 320, 335, and that is the desired result also. This means we have successfully wrote the program to execute the multiplication of two matrices in C programming. Thank you.